Okay, so a piecewise defined function is a function made up of multiple parts, okay? Each one of the functions has a specific domain on which it exists on. So it is pretty much what you guys did with your Desmos project. You guys had one really big piecewise defined function because you had hundreds of functions and they each had a special domain, right? They all existed only on a certain interval, okay? So what is it that this function is? Well, this function is telling us that we have it into three parts. We have the first function, which is 2x plus 8, and that has a domain where x is less than or equal to -2, right? So imagine that this graph was drawn out, but then we are only going to see the part where the x is less than or equal to -2, okay? Then we have another part, another function, which is x squared minus 3, right? That one exists on a domain that is between -2 or greater than -2, but less than or equal to 3, right? So I guess like somewhere in the middle. And then the last function that you have is a square root function, x plus 3, where the domain exists only on x greater than 3, right? So this should be kind of a familiar idea because this is what you did on your Desmos projects, okay? All right, so how do we evaluate these? All right, evaluating them can be kind of simple because all you have to do is find out, well, where does the input exist, right? Along which domain does it exist? That will be the function where I plug it in. All right, so let's take a look at part A. Notice what you're being asked to find is f of -4, right? F of -4. So which one of the domains does -4 belong to? Does it belong to the domain where x is less than or equal to -2? Does it belong to the domain where it's in between -2 and 3? Or is it part of the domain where it's greater than 3? Right? Where does -4 fit in these three different domains? Yeah, it looks like it fits in the domain for the first, right, kind of first mini function, right? Right here, this is where it would fit, right? Because -4 is less than or equal to -1, right? So then that means we are going to evaluate it in this function here. All right. So a lot of it is just identifying where that value fits in order for us to plug it in into the correct function within the piecewise. Okay. So if we want to find f of -4, we're going to use 2x plus 8. Okay. So this would be 2 times -4 plus 8. All right. 2 times -4 would be -8, and then plus 8. We end up with 0. Okay. So f of -4 is just equal to 0. Right? Not too bad, right? So a lot easier than what it may have originally seemed. Okay? A lot of it is just identifying where the input belongs, right? Which domain does it belong to? All right, so let's go ahead and move on to part B. Now we're looking for f of 6, right? F of 6. So where does 6 belong? Yeah, it belongs to the domain where it's greater than 3. Right, 6 is greater than 3. So that means we get to use it in this function, right? We're going to use it in the square root function. So f of 6 would then be the square root of 6 plus 3. All right, so we end up with the square root of 9. And then the square root of 9 ends up being positive 3. All right, any questions there? Okay, let's continue then. All right, so now we have f of -2, right? F of -2. Now, if you notice, -2 is kind of split up across two different domains, right? But if you look at the domains carefully, one of them says x is less than or equal to -2, and the other one is simply greater than -2. Yeah, right. So where does it equal -2? Which domain does it belong to? That would again go back to the first one, right? It would belong to this domain here. right? Because -2 is equal to -2, right? So then we would reuse this function, okay? So we would have 2 times -2 plus 8. All right, that gives us -4 plus 8. So that's actually just a +4. Okay, so it can get just a little bit tricky. You have to be able to know, do I include it or not include it, right? So look for those signs when you have the less than or equal to or just less than, right? So that you know which one the -2 will belong to. Okay. You know which equation it belongs to based on the number, right? So let me take you back to the first one then. -4, right? -4 is -4 greater than 3? No, right? So it does not belong to this domain. Is -4 in between -2 and +3? No, right? It does not fit into those domains. So then the only one that it does fit in with, the only one where it's actually true, is in this first one, where -4 is less than or equal to -2. So because it's true for this domain, then you have to use this function. Does that make sense? Okay. Right. So for each input, you have to try to see what domain does it fit into, and then that's the function that you'll have to use to evaluate. Correct. You're just inputting. So you just have to make sure the game is input it into the correct function. All right. And so you use the domain to help you. All right. And then finally, you have f of 0. And where would f of 0 fit into? Right. It fits best right here, right? Because 0 is in between -2 and +3. It's greater than -2, but less than or equal to 3. So then we would then use the middle function to evaluate. So we would have 0 squared minus 3. So 0 squared minus 3 ends up just being -3. All right, so these would be your outputs on the piecewise function. Okay, any questions there so far on example 1? All right, kind of fun, I think. All right, let's move on to example number 2. Okay. All right, let's take a look here then. So for f of 8, right, this is my input. Which domain does that belong to best? Okay, so third one or last one, right? It fits best right here, right? 8 is greater than or equal to 5. So that means we get to use this function to evaluate. So we're going to do the absolute value of 8 minus 2. So that ends up giving us the absolute value of 6. And the absolute value of 6 is just 6. All right. All right, next one, right? F of 0. So we want to know, where does 0 fit best? Is that going to be first, second, or third domain? Yeah, first one, right? Because 0 is less than 1. So then we would use this function to evaluate. So we end up with 2 times 0 to the third minus 1. All right, we clean it up. 0 to the third is 0. So 2 times 0 is still 0. We end up with just -1. All right, here's one that can be slightly tricky sometimes, okay? There's my input, right? It's 4. Where does that fit best? Which domain? Yeah, second one, right? Because 4 would be greater than or equal to 1, but also less than 5. So it fits best into this domain. What's my output? It's just, think about it, right? Is there anywhere to plug the input in? No, right? What is the output going to be then? It is just 3. Okay, it is just 3. All right, let me show you a visual in terms of like a graph, what this means, okay? Because here there's nothing to plug in. The output would just automatically be 3. All right, and here's why. Let me show you on a Desmos graph. And let me resume share. Okay, so let's say you were going to graph that, right? Just the part f of x equals 3. You see what kind of line you get? It's horizontal, right? Which means what is the output going to be every time? Always 3. Does the input matter? Not really, right? Every input will always have 3 as an output. Okay, so in this case, what we had was 4. So, oh no. It's just 3. Right, so the input does not get plugged in necessarily because the output will still always be 3 regardless. All right, so sometimes that will happen where you end up with a question where it seems like something's wrong because you didn't get a chance to input anything. But that's okay, right? Because it might just be a constant function. It might just be a horizontal line where no matter what, the output will be 3 and doesn't matter what the input is. Okay, so there won't be anything to plug in, right? You will already have the output. You will already have the answer. All right. So just be aware of that one. It's maybe the trickiest one on this type of piecewise problem. Okay. All right. And then finally, last one here. Let me clear so we have a fresh start. F of 5, right? F of 5. So that belongs to which domain? That belongs to the domain here, right? This one, because this one actually includes equal to 5, right? Yeah, it would be false if you included it in the second domain because the second domain, 5 is not less than 5. But in the third domain, 5 is greater than or equal to 5, right? There's the equal sign that we're going to follow. So we're going to use the third function then of absolute value of x minus 2. So we end up with the absolute value of 5 minus 2, which is absolute value of 3, which is just 3. Okay. No, there has to be like the number has to fit within one of the 3 domains. So the input that you're given will have to fall into the first, second, or third domain. All right, because the overall over the whole graph, it has to be defined everywhere. But that's a good question. All right. Anything else before we move on to the next example? All right, let's keep going then. Okay, now we're gonna do the same thing, but now in a graphical evaluation, right? We're gonna evaluate graphically. So now we're given the graph, and this is what a piecewise function looks like on a graph. You have basically multiple mini functions, right? Multiple mini functions. So you'll see how we have our first function, which is maybe a line, right? It looks like a linear function that ends at this point. You have a second function, which is not defined at -3, but then is constant and then not defined at -1, right? So that one has holes, but it's constant in between -3 and -1. And then finally, you end up with a function that is also what appears to be linear, right? Straight line, but is not defined at -1 either. Okay. So we're going to look at what is the input and try to find the output by just analyzing the graph. Okay. So we did this similarly at the beginning of this unit. Now we're revisiting, but using piecewise. Okay. So let's do what we did before, right? We're looking for the output when the input is 2, right? So think of this as f of x. So what are you given? You're given the input. Input is 2, right? So when x is 2, right? X is 2 here. What's our output? We have to go meet the graph, right? So you go down and you'll see that there is an output. There is a point there at -1. All right. The output would be -1 when x is 2. Okay. All right. Next one. All right. Here's a tricky one. What is the output when x is -3? Right. We want to think of x is -3. So we go to -3. I want to go up and meet the graph. Okay. Now, what do you think? Is it undefined? Is it 2.5? Which one is it? Okay, so there is an open circle, but then above that, there's a solid circle. Which one wins? Yeah, right. Remember that conversation we had? Solid overrides open? Same thing happens here. It's not defined here, but if you keep going, it is defined further up. So you go where it is defined. So if I were to go to -3, I do have an output, but the output is at 2.5. Okay, so if I have an open circle, it's like I can keep going right through it. Okay. So this output would be positive 2.5. Now let's say that this dot was not there at all, right? Then it would be undefined, right? If the solid circle was not there, then it would be undefined. But because there is a solid circle, the solid circle would override. This one tells you this is my legitimate output. Okay. So that could be one of those tricky ones, right? -3, right? You have an open and then you have a defined. The defined closed circle will override. Okay. So that's the one that you use for your output. Okay. Are we clear on that? Good. Okay. All right. Another tricky one. -1. What is my output when f or when x is -1? Well, I go to -1. Right. If I travel up, am I defined? No. If I travel down, am I defined? No. So in both situations, I'm undefined. Therefore, overall, what is my output when x is -1? Undefined. Right. This one does not have a defined output. Okay, it has open circle in both directions. So neither one of them gives me an output. All right, so I'm undefined. So at -1, there's no defined point. Any questions there? All right. And then last one, f of -4, right? What is the output when x is -4? Well, we're going to travel to -4 along the x-axis. And what is my output? That's right. It would be 2, right? We go up to meet the graph, and then that point is +2. So those are my points. Those are my outputs. Okay. Any questions so far? Not too bad, right? Also kind of fun, I think. Okay. Are we ready for example 4? Let's do it. Okay. So let's just quickly make sense of what we see here. Piecewise function split up into 3 parts. Linear function here, defined at -3. Constant function, not defined at -3, but then defined at -1. Okay. And then we have, what does this look like? What name would you give this function? Or what family does it fall under? Yeah, they have families. There's families of functions. We studied them in Unit 2. What does that one remind you of? Not quite. Parabolas are U-shaped. This one's not really a U-shape. We didn't really learn about logarithms. We didn't really cover exponential either. Yeah, square root, right? This is a radical, right? Radical function, square root function. Yeah, he did a bunch of them on the Desmos project. So linear function, constant function, and then square root function. All right, but the square root function is not defined at -1, right? So those are the 3 pieces. All right, let's talk about now those outputs. All right, f of 0, right? When x is 0, what is my output? Yeah, it's just 2, right? We go right up to meet the graph, +2, nice and easy. All right, let's talk about when x is -4. We're gonna go to -4 along the x-axis. What's my output? Yeah, +1, very good. All right, here's the fun one. Here's the fun one. When x is -1, oh, I like it. -2, right? Because if you go up, it's undefined, right? There is no y value up there. But if you move downwards, you're going to meet the defined point, which will be -2. All right, very good. And then finally, f of 3. We travel to 3 on the x-axis, and then we're going to move up to meet the graph. It's defined there at +3. Right? It's fun, right? I love it. It's one of my favorite lessons. Here's a bonus one. F of -3. What should your output be? You sure it's 1.5? You sure it's not undefined? Positive? All right, I like it, right? 1.5, right? You go over to -3 on the x-axis, right? If you go down, it's undefined, right? So there's no y value there, but if you move up, you'll see the point. There you go, 1.5. All right, good. All right. And now let's move on to the last one. This one is the last problem that is printed on your worksheet. So you have to go all the way down to about page 4. Okay. All right, let's quickly work our way through this one. You will never enter undefined and 1.5. You can't be both. You can't be undefined and 1.5 at the same time, right? So it must be 1.5. All right. All right, let's move through them. All right, so now we're looking at output when input is -1. What is our output at -1? I know I skipped the page. I went straight all the way down to page 4. Okay, the graphing we're going to do next lesson. Right now we're just doing evaluating. All right, so when x is -1, that's right, we move over to -1 and we're already on the graph. Awesome, so that output would be 0. Good, okay. What about when f is 2? When f is 2, when f is 2, when x is 2, what's the output? Yeah, it's 1, right? Look, you got that constant function, similar to the one we saw already, right? Where it's going to be 1 the entire way through. So when x is 2, output is 1. Okay, what about when x is 1? Yeah, 1 again, right? You travel to 1 on the x-axis, you move up. Hey, it's defined at 1. right? So you can stop. You don't have to keep going. You don't have to say it's undefined because it is defined at 1. All right. What about f of -2? What is the output when x is -2? Yeah, that's -1, right? So kind of the opposite. You move down, you see the defined point, you can stop there. Even if 1 is undefined, you don't list it though. Okay, so it is only just going to be -1. And then finally, when x is 0, what's our output? +1 again. Okay. All right.